Hey everyone, here's our math problem for today. Let's begin with this circle O and this quarter circle ABC. These two figures are tangent at their points of intersections at A, B, and C. It is given that the length of side AB is 5 units and the length of side BC is also 5 units. You would like to find what is the area of this blue shaded region. You can pause the video and see if you can solve this interesting geometry challenge. Now let's solve this problem together. Let's begin by constructing this right triangle. For the purpose of identifying this upper arc, let's call this as point D. What can we say about this arc ADC? Notice that angle ABC is an inscribed angle, and therefore its intercepted arc ADC must be twice the measure of this inscribed angle, which is a right angle. This implies that arc ADC is a semicircle. Its measure is twice 90 degrees or 180 degrees. This also implies that AC is a diameter. Now let's compute for the measure of this diameter using this right triangle ABC. Using the Pythagorean formula, the hypotenuse is equal to the square root of the sum of the squares of the two sides. In this case, both the two sides measure 5 units. So you have here 5 squared plus 5 squared, which is simplified as the square root of 25 plus 25, or the square root of 2 times 25, and the square root of 25 is 5, so this simplifies to 5 square root of 2. And let's remember this result. 1/2 of that is the measure of the radius. So the radius OA, which is equal to the radius OC, is equal to half the measure of the diameter. So that is 5 square root of 2 over 2. Our goal is to find the area of this blue shaded region. And notice that the area of this blue shaded region can be computed if we find the measure of the semicircle and subtract the measure of this segment of the quarter circle. Therefore, let's detach these two figures, compute for their respective areas, and subtract the result. That will give us the area of this blue shaded region. So let's begin finding the area of this semicircle with a radius of 5 square root of 2 over 2. The area of a circle is pi r squared, and if you divide it by 2, the result is the area of the semicircle. Let's simplify this. This becomes pi times the square of 5 is 25, the square of the square root of 2 is 2, so 25 times 2 is 50. The square of 2, of course, is 4. Copy the denominator. This simplifies to 50 pi over 8, which is equal to 25 pi over 4 in lowest term. Let's remember this result. Then let's find the area of this segment of the quarter circle. Notice that this segment of the quarter circle can be thought of as the difference of two figures, the quarter circle itself and this right triangle. So let's separate these two. What is the area of this quarter circle? That is 1/4 the area of a circle with a radius of 5 units. So area is pi r squared, and we divide it by 4. Simplifying, this becomes 25 pi over 4. Now for the area of this triangle, its height is 5, its base is 5, so area is 1/2 base times height. This simplifies to 25 over 2. Therefore, the area of this segment of the quarter circle is the difference of these two areas, and we now have this result. Area is 25 pi over 4 minus 25 over 2. Let's go back to our previous result. We said that the area of this is 25 pi over 4, and we just computed that the area of this segment of the quarter circle to be this expression. If we take the difference of these two areas, the result is the area of the blue shaded region that we are looking for in this problem. So let's compute now for this. Since we have here a minus sign, we distribute this here and we distribute to the other term. So 25 pi over 4 minus itself is 0. Then this negative times negative becomes positive. So the area of the blue shaded region is 25 over 2 square units. And this is now our final answer.